first chapter will be introducing the digital signal processing. So, if I'm not mistaken, I did mention about what the chapters that will be covered by our subject for the whole semester yesterday. And then, so this is the first one, maybe slightly more on introduction to the digital signal processing, I guess. Okay, so what are the learning outcomes which need to be gained by the student at the end of this chapter? So the student are expected to be able to explain what is the signal system, digital signal processing. So this is actually meaning that at the end of these 37 pages of this slide, so all the students, 27 students, are capable to explain what is the signal. The first one is actually the signal itself. So what the signal is all about, and the second one is the system. So meaning we have a signal over here. So what is the system that will involve or filter designing for the system? And lastly will be the whole elements from the signal and system, and finally we have the whole system called as digital signal processing. And then for the next one will be student need to recognize the importance and the benefit of the DSP. So this one is more likely to theoretical rather than explaining and answering or calculation problem. So, and at the end, distinguish between the digital and analogs. So before I start the lecture, so this is the digital, right? This is digital. So what are the difference between these two? So there are things that we need to be confirmed before we started to use the digital and analog itself for the signal. So whereby the time given in discrete would be this way, and the time given to us continuous patterns would be that way, this way. So normally you can say in various books they call it N. Are you familiar with this? This and this, right? So we have this one is what we call it XT round bracket. This one is shut bracket. So this is actually referred to discrete and T is continuous. So later on we discuss about that. Okay, I think that will be an introduction. So what is the signal? The first one would be this one, right? The first element need to be covered is this, and later is this, and this one is this. Okay, so step by step we will go on the first one. So signal is actually the variable that carries or contains some kind of information. So, okay, so meaning to say the information can be conveyed, displayed, and manipulated. So the meaning is, the keyword over here is actually this. So what is this information? So information in simple word we can say that example, you remember the cup experiment when we do at the secondary school? So this is paper cup. So this is the kind of any kind of benang or ropes. Okay, so this one is 1%, and this one is 1%. So this one say hello, and this guy will be hearing hello, right? So that would be a signal. So signal, basically we can say that things can be conveyed. Okay, so meaning there will be movement from A to B or C or D or something X, Y. Okay, so related to what the things that related to the display is actually there are many things to be discussed about this term. Can be displayed. Let's say, okay, you have an iPhone things. Sorry, my sketching. So this one is actually the signal coming in. So one of those, because we know well about this, we know well about this, we know well about this, and etc. etc. Right? So everything's happen from the what they call it, GSM or LTE communication center to our cell phone. That will be the signal. Okay, so okay, the third term is manipulated. So manipulated means manipulasi, diubah bahasa Melayu. Meaning, if let's say that we have saya. So if we want to change or manipulate saya, meaning we can say in the time we have, I'm not sure, saya in T, but the real things happen in the voices after you pull from your mouth. It's actually this one, yeah, wave coming from your throats. So that would be the signal, original signal given by God. Okay, so then what happened to the signal is actually being converted by this earphone, so microphone over here, and then we transform to the digital, okay, the digital, and then later on there will become a terms called DSP soon. Okay, that will be the idea. So for example, speech signal, so the one that I mentioned earlier here, over here, and electrical signal, voltage and current, this is, I think everyone knows about this because it's been covered well in circuit theory, right? 1 and 2. So this one is output and this one is sources, and this will be the independent based on the T independent. So T is actually independent by itself. So that would be the idea. So remember about what we discussed just now about T and N. Okay. So this one is AC or DC, this one. Okay, another things to be understood is the signal itself can vary with time, frequency, and space and distance. So what are the things can be discussed from here? We have, sorry, this is not a good idea to use. It's better to use red instead. Yes, correct. So we have time, we have frequency, we have space, we have distance. So in a normal term of engineering, basically we know the things related to the time, right? So in a bit unfamiliar things regarded to the signal is frequency. So have you heard about Laplace transform before? Fourier transform, normal one, I think, in signal system, right? This one is a space, this one is this distance. So these are the things which can be reflected to what they call it a signal. So whereby this one would be xt and this one would be xf and this one etc. etc. Okay. So examples, a speech signal can be referenced by the amplitude and frequency. So this one is more or less related to this. Frequency and phases is coming from the F domain, and this one is time domain. So this one is sinusoid function. So we have this one is the A, and this would be omega, and this one is the phase, right? So in T, what is T again? It's continuous, right? Okay, then we go to the example of the signal with the function of two spatial coordinates in a plane. So whereby they have x and y at the same time. So or we can say this. So this is not normal like txt, right? So this one is one coordinates for the time domain. So as easy example is black and white image, light intensity with two spatial coordinates. So I guess this one is the most easiest. Hold on. The most easiest example. So let's say the black is example is 0 and white is 1. So in order a signal to identify this black or white is how intensity value from 0 until 1. So this is the light intensity that we call it, or we can say color intensity. for introducing either black or white or white or black. So this one can be changed by the programming code. So speaking of which, video signal in TV, we have sequence of images. So likewise, we have like this. So do you remember when I was in secondary school, saya buat dekat tepi buku teks orang-orang yang bergerak kan? Lalas dia berlari. Remember the story? My time was there, but I'm not sure your generation. So meaning to say, sequence, we have an image. So we run the images as a sequence and it becomes many frames. So at the end, the object will be moving, right? So that would be the idea of telling what is the signal related to the videos. Two spatial coordinates and time. Okay. So these are our example that we have. This one, anyone knows the signal? You can put on the text even if you have idea about this. Okay, so these are what we call it the wavelet signal, which related to this. So this one is the one that I think many of you did, this one. But it depends, somehow I'll say this is actually the one, Dobitschis. So it's like maybe it looks like EEG and ECG somehow, but it depends on the application that we use. So this one is normal one, a normal sines, and this one say that the amplitude happen to be a noise, and this one signal plus a noise, meaning this one is a noise signal. So signal plus noise. Hingar plus isyarat. This one will be this. But the thing is, in image processing, we can see that the hairs is actually having a structure that we can see right now. The company of telecommunication are struggling. Have you heard the bokeh one, the thing? So meaning separating the background to the foreground. So this one is, so they are the targets at the point of time is actually separating the foreground and background. So not more than that. But nowadays we have every single camera in the cell phone right now having the, what they call it, depth sensor bokeh things, and become familiar right now, right? But the one happened before is actually age detection when it started, right? I think more or less 2000, 2002. The time was the field become a boom things, but nowadays it's a normal things because has been embedded in all handset, cell phones. Okay, and this guy I'm not sure, but it is familiar with, because this is video captured by an image that time. It's not a good image quality by the way, but it is happened in 1990s. This one is the one that happened by. So let's jump to the types of signal. So before we begin the type of signal, let me jump a bit at second page. So I did ask somebody what is digital and analog, right, just now. So these are the thing. Signal is initially has been differentiated between the two. So the one is continuous and the other one is discrete. So continuous by name is basically reflect to the this we have, and so this is actually happening by t continuously, whereby this one, so say that we have this signal and we pull out to the discrete, just now the same idea that we have. So this one is called discrete time. So that would be n and this one will be t. So this one is no matter what, a n or xn, whatever, a t. Okay. So this is continuous. This is discrete. Okay. So if we talk about continuous, there will be things that related to this one. If I may add a bit later on. So this one is related to this. If I may add a bit. Have you seen this one before? Let's say this is I, this is I, this is 0, this is N, this is AB, etc. So the reflection between those two, this into this, is actually convey a meaning behind the story. So yeah, we need to deal with that, because I'm not the one who will teach you the mathematics, but the other way around is you need to know what is the maths going at the back of the theory. So let's say, so the history behind, do you know this word, area? What is the equation called? This one is summation, right? So what is summation is all about? What is the area is all about? So it's actually, I just portray to you a bit, unless you don't like the things behind the scene. I want green instead of red. Okay, this one. So basically, A and B is actually the location underneath of the graph, right? Let's say this one is B. So xt is actually, okay, A and B has their own value, right? Let's say this one is 5, this one is 20. Okay. So t equals 5, t equals 6, t equals 7, etc. etc. to 20, it has their own, what you call it, we can call it a pillar. So the philosophy behind this one is actually the summation of the area which cover underneath of this line. So that's what we call it integral. So this is actually, that is the story behind the scene. And if you take a look at more details on continuous, there will be further discussion on maths subject. So continuous value and discrete value. So okay, so continuous time means by the time the value is continuously or discretely. Okay, so let's say we know that the signal is a continuous time, obviously t, and discrete time, obviously n. Okay, so meaning they are not really they are not totally same, but basically there are time both. So the continuous happen all the time, frequently, and this one is discretely. So continuous value meaning the value is actually happen all the time from A to B, but the discrete means originally there are continuous time, but the pattern will be a bit different than a normal continuous time signal. Okay, like this. So it same goes to this, and finally that we call it analog. The whole lot of the signal using T, continuous and discrete, is referred to the analog signal. And then speaking about the discrete, so we have this, the same, discrete signal and digital signal. So that would be the idea. Okay, so the one that I mentioned earlier about the, we have continuous time, right? This one. Okay, I change back to the blue. Hopefully, okay. So this is blue right now. So blue has continuous value, right? Continuous time, continuous value, and discrete value. So this is actually reflected this. Continuous is actually the first one, the first terminology, while the later one is either continuous or discrete based on the amplitude. Okay. So we can say here both is T. Okay, this is using N. Okay, later. T. Where's my pen? T. So this T is round bracket, right? We can see over here clear. So this one is actually continuous time, obviously by T, and continuous amplitude. So amplitude meaning the changes between on the x-axis, right? This, so that will be continuously changed. So this one is discretely changed, meaning this one is 1 from this range. For this range will be -1, and etc. etc. So the changes of the amplitude right here is actually the discrete amplitude, but continuous time. Okay. So for the one that we mentioned earlier just now, how about the discrete? Oh, tak buka. So discrete time, we also have continuous and discrete in terms of amplitude. Okay. So this is actually if we can sketch back to the analog, so this seems to be, so take a look at this. This is actually the changing from this to here, xt to xk. Okay, so while this one would be precise, so I think you can imagine the changes from here up to here. Okay, that would be discrete time, discrete amplitude, so that would be things.
Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.